He has done so many accomplishments, from being a rescue diver to being like a rescue forest ranger. I might be making that part up a little bit, but you help rescue people somehow. He rode a 100-mile bike ride on a folding bike, which, yeah. Do you know how hard that is to do? He also ran like a bike race around a park in New York City where as a folding bike, Le Mans starts. You have to run to the bike and unfold the bike, take it apart, and like set it up. It was amazing. So many cool accolades I can give to this man. Wrote a great book, Pandas for Everyone, which we're going to give away copies of Pandas for Everyone. Actually, as soon as he's done speaking, we'll give away a copy of it. So many things I want to say to Dan. He was my student 10 years ago, and now he's a lecturer, has his PhD. Everyone, please welcome Dan to the stage.
So today I want to talk about sort of like what I've learned doing a dissertation project. So it's really a big analysis work and generating reports and projects, and then sort of like what I've done and what I would sort of improve upon it. And so I want to share those results with you. First, I would like to acknowledge that we are currently located on the native lands of the Munsee Lenape people, which is just north of us is also the peoples of the Wapiner, and to the east of us is Canarsie. And then the work that I did was actually in Southwest Virginia in Roanoke, because I went to school in Virginia Tech, and those belong to the native people of the Tuledo tribe. And so also, I would also like to give thanks to Beatrice in the Our Ladies community for helping create this Quarto template that I'm using today. So yeah, like Jared said, I finally graduated. For the longest time, it was every single year that the NYR conference ran was another reminder that I had to go graduate. So I finally did it back in December. And so yes, so I'm currently a teaching postdoc at the University of British Columbia. I also work as a data science educator at RStudio. I helped Jared with stuff and wrote some things. And I've also just recently sort of like gave up my duties working with the carpentries just because there was too many things to do. But yeah, so today, again, I want to talk about combining analysis work with reports and presentations. And so this is a topic I talk a lot about, so you can look through previous talks that I've given. I also teach a lot of this content pretty often. And I really want to just go about how would you go work with these best practices, given that you actually have like constraints, like time constraints or other types of constraints, and then like how can you set things up so you can make incremental improvements and learn incrementally. And so, yes, there's going to be a lot of things that you may or may not be doing right now, but treat it as like, hey, the next time you try a new project, like time box your learning and try that out, and then if it doesn't work within like 30 minutes to an hour, like just give up and do your own thing, but at least you gave it a shot. So back in 2019, I think it was like the last time I spoke in front of live people, I gave a talk about building reproducible and replicable projects. And this is important because when you have your analysis work that is reproducible and set up in a replicable way, you can build in more features, you can move to like other compute servers, and it makes it a little bit easier to work with other people. And so first, let's talk about the analysis project structure. For those who are academics, you can actually reference this paper by William Noble that really outlines, hey, if you really need to work on analysis, here's some folder structure if you don't know where to start. And the main parts is you have like a folder for data, you have a folder for documentation things, and then a folder for results, and then code. So that can either be source code or like a binary, depending on what language you work in. But those are like the main general folders that you should start off with when you do your work. And so in my dissertation, I did something pretty similar. This is all in one giant folder, but there were really two parts to it. So on the left-hand side, you see all of the files and folder structures used for like the project itself and packaging. And then there's also the series of folders I use for like the actual bits for the analysis. And so you can see like I have an analysis folder. It's broken down into sections. There's a way to call those analysis scripts. My data is getting loaded from somewhere, and then I have like outputs of various things being saved out. And so the first thing is knowing how to name things. So there's these two resources, one by Carl and one by Jenny. And essentially, you want to make sure that your files are machine readable, but also human readable, but then also plays well with like natural sorting. And so mainly with dates, like please use ISO 8601. And then the other thing that Jenny Bryan has said, that really only get as complex with your naming as complicated as the regular expression you're able to write, because you can use your file names to sort of, you can parse out information later on, and you kind of don't want to write like this gnarly regex thing that you don't really understand. And so that's naming your files, but then you want to actually go and create a project. So the way you do that in RStudio is in the top right corner, you can click on the little R in a box icon and go to New Project. And what that allows you to do, in combination with a package called here, is it will find the starting point of your project. And so that means that as your project evolves and you have to move scripts into subfolders and stuff like that, you don't have to like go back to that part in your file and like change the data path. Because if your data isn't moving around and you're just moving around your R scripts, that's totally fine. It'll be able to find it. And then the other thing that's really useful is because I'm working in a Git environment, I'm only really committing like the final artifacts that I really need. So like I'll have like exploratory plots and all of that, but the ones that I'm actually using for a presentation or a report, I will explicitly save those out using like something like ggsave, and then actually commit those into the repository. So next, so that is like the setup of the project. What about the actual like underlying code bits? So one thing that I sort of realized, people talk about testing code all the time in a lot of these like workflow talks. But I felt that like since I'm really just doing analysis work, it kind of doesn't make sense. Like if I'm writing a function and all this function is doing is selecting columns and filtering rows, do I really need to write a unit test for this? Probably not. And so, but I still end up testing my work, and I use stuff like stop if not, or the test that package, or the checkmate package, to still make sure that like things are doing as I think, like hopefully the way that they're working. But that is the difference between like me being an analyst versus me writing like research software. And so in your own code, what you can do is, for example, use stop if not, and if some value is equal to the value that you're testing, then nothing happens. Your code will just silently just keep running. But if it meets a condition that isn't true, then your code will actually stop and halt. And so that's like a way where you can sort of pretend that you're unit testing. It'll set it up for a unit test later on. But this is still some way that you can still check your work even if you're working with your own like types of functions. And this is also really useful if you're reading like sensor data and you know that like this is supposed to be 300 rows and 300 columns. You can write a test for that just to make sure that your data is being read in correctly. The other thing that's really useful is pinning your package versions. So there is a library out of RStudio called rm. And the way you use this is in rm, you call init on your package. It creates this rm lock file. And then all you need to do is say rm snapshot. And all of the packages you have installed will get put into this lock file. And then if you migrate to another machine or something else, since you already checked in that lock file, all you need to do is run rm restore, and it'll sort of save all of those package versions back into your environment. So that's another way where you can at least make sure that if you're working on like 2 different laptops or 2 different systems, you have the same exact version of your packages. The thing that I would actually improve about the work that I ended up doing, so I do end up making all of these random source calls, but I had set up my project in like an R package format. I just never used it. So for me, I ended up using the here library to find all of my scripts, and then at the top of my, a lot of my analysis scripts, I was just sourcing this stuff. But I learned that there's an actual better way of doing this. And so the way you would do this, or the way I would improve upon that, is actually go and make the description file, since I already have the capital R folder. And really all you need to do is if you put in the top of a description file, type is project, then at the top of my code, all I needed to run is package load all, and it would have like sourced everything for me. And that makes it really nice, or even nicer, when I am trying to tweak a function. All I need to write is run is package load all, and then all of the changes I made for that function just got loaded up. I don't have to like even find which file or which line to source. It sort of just treats it like a package without actually setting it up as a package for CRAN. The other thing that's really new, and I haven't even looked into this yet, but if you're on a Windows machine, you would have noticed that like if you install multiple versions of R, there's like a way for you to actually switch R versions on a Windows machine. If you're on a Mac, there is an application called RSwitch that allows you to do that as well. But there's this new application called Rig, and essentially this is the operating system agnostic way of installing multiple versions of R on your computer, so you can toggle between R4.2 and R3.7, 4.0, et cetera, et cetera. So this is another way of saying that, like, hey, I've version pinned not just my packages, but the actual version of R as well. And then the other thing that I did was with my build environment. So what I ended up doing, because all of my stuff was in R scripts, I just had one R script that was sort of running the knitter commands to knit everything or calling those scripts. It kind of worked for my use case. I didn't mind just running my entire analysis every single time I needed all my figures updated or some set of figures updated. It took like 30 seconds, so I didn't really care too much. But the way, if I really, and I should have spent the time learning this during my dissertation work, but I would have really looked into this targets package where it would actually formally, where I would formally track how the objects are dependent on one another. So like this figure relies on this script, and this script relies on this cleaning script, et cetera, et cetera. And then I would run targets, and it would figure out like which actual script does it need to run to generate the figure. So it didn't have to like run everything. It'll be a little bit smart about like only run the parts that need to be run, because those are the only scripts that you've changed. I also, in general, I tend towards leaning towards using an application called Make. And essentially, it's doing the same thing, except it's not specific to R. And there was a talk about Make from that talk that I have linked that you can look up later. So next, the other thing is a dissertation has a bunch of different components to it. So what do you do about all of those other related projects in this overall project? So for example, in my work, I had at least 8 totally separate repositories. And I needed a way to keep track of all of them. And so yes, you can have a heuristic where you're like, OK, every time you clone down this repository, make sure it's all in the same folder. That works. But it still means that like I have to like go make sure I hunt down like all 7 or 8 of these links and then make sure that I clone them all in the same place, et cetera, et cetera. So like I had a whole series of projects around that were book down based. So this was before Quarto came out and was a thing. I had certain projects that were mixed and weren't using reproducible formats. So like my IRB application was this Word doc that I had to submit. Some of my presentations were on Google Slides. So I just downloaded those into a repository as a PDF just so I had them, but they weren't really in a reproducible format. And then the other issue that I had was finding a way to collaborate with and without Git. So mainly with my actual dissertation writing, I ended up pushing up to my Git repo, and then I had my advisor look at the repository since it was synced up with Overleaf. And so like all of her comments were through Overleaf, and I had to do the work of like synchronizing all of that work down. And I don't really know of a great way to like, other than using Overleaf, where you can like coordinate on writing like a technical document where one of those party members doesn't know how to use like Git as a version control system. But this is sort of like my workaround around all of that. As you are writing these like really complicated documents, one of the things I would highly suggest you figure out at the very beginning is learn how to use the child documents in whatever system you're using. And so for me, my whole dissertation was written in LaTeX. And so like I had this main tech file, and using subfiles, you can create a link to another file. And then in that link, so this was in the introduction chapter of my dissertation. And then so in the introduction chapter, it had a whole bunch of other subsections to it. and each of those subsections was linked to another file. And the reason for this was, again, I had this weird like overleaf integration thing going on, and so if anything horribly happened, it only happened in like the 3 paragraphs of writing that was going on. And I also didn't have to scroll down through like thousands and thousands of lines when I just needed to edit a certain thing. So child documents does end up making the actual project repository look more complex, but it's just so much more like usable and like, yeah, I'll leave it at that. It's a lot more usable just because you're not staring at like hundreds and thousands of lines of like just straight up text. And then so for something as complicated as like compiling a LaTeX document, this is where I use a makefile. And one of the things that I put into my makefile is by default, make defines a command called all. And then what I write in my makefiles is I put in 2 hashes, the name of the command, and then like some simple description. And then with the power of grep and sed, what this allows me to do when I set up my makefile is when I run the command make, it sort of just dumps out like, here's a little shortcut of all the things you can run. And this helps you from catting this file and trying to figure out what are all the things that I can do. If you leave like these little breadcrumbs for yourself, you can get like a nice little output like this. And this helps a lot when you're like sort of panicked writing and trying to just get things working towards the end. And so what I would actually change is, since Quarto is now a thing and it allows you to sort of use LaTeX templates, that would be the next thing that I would try to look into. I had thought about using knitr and LaTeX, like the RNW files, but I still have to synchronize everything with overleaf because just so I can get feedback from my advisor. And so like I don't know if that's still like a great idea, mainly because like I still have to do that overleaf integration. But if I didn't, that's what I would actually do, because then I would actually be able to load up those resources in R into like the actual tech document. So I talked about all of the different repositories that I had. And so that was the other big challenge of like, how do you actually go and keep all of these pieces together? And so the way that I ended up using this was through using some part of Git called Git submodules. And so one of the rules around using Git is don't nest your Git repositories. Like if you git clone or init something, nowhere in any of those subfolders should you git clone or init another folder. But Git submodules sort of allows you to have that feature available to you. And so what I ended up doing was I had this big giant project called my dissertation. And then in a subfolder, I had all of my other Git repositories. And then so, for example, my analysis repository, which was its own totally separate Git repo, I had it, and I was able to access it as if it was just a regular subfolder, and it was treated as 2 totally separate Git repositories. And so that's what Git submodules allow you to do. I'm not going to go over how to use Git submodules, but essentially, each submodule is its own repository that you probably, if you know Git and GitHub, just treat it like a regular repository. The only difference is when you commit and push to GitHub, you have to go back to the parent repository and then do another round of adding and committing. And that second round of adding and committing is all it's doing is keeping track of like the actual commits that it should reference to in the submodule. But the other way you can think about it is when you use Git submodules, the mental model kind of is like nested Git repositories, and you just have to track the one inside totally separate from the one outside. But you have to do it twice. And so if you look at the actual parent repository, it will look like this on GitHub, and you'll see that it's really only tracking like the last Git state. Like that's why you have to make this separate commit on the parent repository. But inside is totally normal, and you can just treat it as if you weren't working in a Git repository, and that's really nice. But now the benefit is I can clone down one repository, and all 8 repositories can come down with it. And I can rely on that relationship between those subfolders if I needed to. And then the last thing was the actual like experiments, some of the experiments that I ran. So in short, I would really, so I ran an experiment that relied on Shiny, but I sort of out of time, sort of just did something really janky with it. But if I were to do that part over, there is this library called Shiny Surveys where you can actually use Shiny to administer and give out surveys. And what that also allows you to do is you can build in a randomization process in there. So people can come to the app, put in an ID number, and then they get randomized to something, and then you can administer your survey that way. And I should have done things that way, except for me, I just ended up as people were coming into the workshop to take the survey, I would note their names, and then I would do the randomization for them, and then give them back their IDs, and it was this whole mess that took an insane amount of time in the beginning. So that's something that I definitely would have worked on better. So in sum, what I would have changed is I would make a description file and put in that type equals project, use rig to manage multiple versions of R, since other things, I had other projects going on. Targets and a makefile, I should probably have used those a little bit more, but I didn't. Quarto is now a really cool thing, this presentation is written in Quarto, and I really want to be able to explore that more, and then Shiny surveys. So with that, thanks.